Charge it at noon. Always takes about 30 seconds for that to link up. I decided just to do straight to YouTube without the Zoom because it complicates things. It makes it a hybrid deal. It makes it and quite frankly, it makes it feel better. Come on. Now let's see how that, you're looking in. Okay, we just got to turn the camera a bit. Try to
Got a message here from
oh,
Carol Forex. He's not going to be able to make it.
oh,
Trouble.
oh my goodness. And he's got a Lincoln Town car, like he's got a Panther platform vehicle too. I'm trying to get it where you're going to stand more or less where you can see your slides. And okay, so this needs to be turned. I need to move the camera a little bit to the left. Let's try. You just glance and see yourself on the screen. John, can you move that tripod into where I'll tell you where to stop. All right, folks, we're just getting warmed up here for our 10th annual TechCon. Okay, move over a little bit this way. Good. Go this way. I think it's backwards. Why is it not moving? Let me adjust it a little bit. A little bit more that way. It's weird. Oh, that's kind of weird. No, it's not. But I'm not seeing the camera move. That's kind of strange. I want to get. Well, if you could stand here, that'd be better. You'll be centered in the video. You can just watch yourself there and center in the video.
I try not to watch myself. It's painful.
Yeah, well, I normally would say ditto, but we're trying to make a good product. So we'll keep an eye on you. All right, let's see here. Testing. We're going to go and get started here just momentarily. And thank you very much. And by the way, just a housekeeping note. This will be one continuous or two streams today. We will do the morning in one and the afternoon in the other. Russ N4RTD has generously agreed. He could not make the conference today. He has generously agreed to go back and clip these into individual videos and insert the slides into them. So it's going to make for a really nice finished product. So, so that way if you missed it on that, you'll be able to go back and watch the edited versions and it'll be a very nice product for you to enjoy. All right, I guess with that, welcome to the 10th annual TechCon. I apologize. I'm not better prepared this year than I have been in previous years. My mother went to be with the Lord 1 year ago this month, as a matter of fact. And then I got to where I couldn't hardly walk. And then on June 7th, I had atrial fibrillation. And I got a new job working in IT in an elementary school. And they keep it moving, shall we say. And that I cut into some of the free time I used to have. Between when I drove a school bus, I had it between bus runs. I don't have that anymore. And when you get home at the end of the day after dealing for 7 hours straight, sometimes without breaks, you think, I don't feel like doing anything. I'm tired. So my apologies. I will try to be better prepared next year. We're going to go ahead and announce some changes that, and I'd like to have the input of those in the room today throughout the day. I want you to chew on these concepts. We're thinking of making two minor changes to the platform as we currently have it. The Saturday sessions will stay the same. That's not going to change. So you go breathe a sigh of relief. But we're thinking about doing away with the Friday evening social because it's the last few years it's just not been well attended. We only had 5 of us last night. So if folks want to get together on Saturday or Friday night informally, I'm game. I'll be glad to come join you. But we will not have a formal Friday evening social in following from this next year and on. We're going to take the Friday afternoon workshop due to, and I got some good advice on this from an Apple support tech and ham radio I know well, that we're going to move the Friday afternoon workshop to Saturday. We will make it a 3rd track for those that want to do it. You can then, and knowing the other 2 tracks are recorded, you won't miss out on anything. So we're going to move that to Saturday, and I think that'll be much better. That was a concept I borrowed from DCC, the Digital Communications Conference, and we did it for 3 years. And it had about 10, 12, which was fine. But when COVID came along, it got killed off. We tried to bring it back, and between mom being in a nursing home, I couldn't prepare last year, and this year being sick, I couldn't do it either. And we haven't had anybody step forward and offer to do it. So we're going to move that to Saturday, and hopefully this is a call. If you want to do a workshop on Saturday at next year's TechCon, see me. If you got a topic, it is up to you what you do your presentation on, as long as it's ham radio related in a reasonable way. So, and also we're going to put out a call for general speakers for TechCon. We were a little short this year, and I want to give a special thanks to Gordon Gibby, KX4Z, for doing some extra programs for us this year to fill in some empty spaces we had. So definitely, please, if you've done a program in the past, like I'll give an example. Paul, his program changes enough every year, he updates it. And that's fine because things change. Things get added. Some things that don't work get dropped. And I think it's a great thing to have these, programs you repeat when they change enough in a year. So don't, every couple of 3 years, you can redo a program as things change enough. That makes new material for your audience. So that's a general call. Please be working on those programs next year, because we have to have presenters to have TechCon. It don't just happen. It takes a lot of work to put it together, and a lot of work on the part of our presenters. And so, Bill, I'm going to turn it over to you as local host, and you may introduce our emergency management representative. Here's Mike.
Good morning, everybody. Welcome to Hillsborough County EOC. This building is rated for a Cat 5 storm. So if there's any emergencies short of a fire, we'll just stay right here. If there's a fire, we need to go out and cross the street, and we'll meet out there. Passing around a sign-in sheet right now. Please make sure you're on it. We need to get a good count of who's here for many reasons. A little bit of housekeeping. You go out that back door where it says exit, go down to the wall and take a left. And the second door on the right is the men's room. The third door is the women's room, and filtered water fountains are in between them. There is no smoking on county campuses. So if you have to go out and cross the street on the other side of the road. Any questions about any of that? All right, I'd like to introduce our logistics chief for Hillsborough County. He's my boss, although he says he can't control me. George Stewart.
Because if you don't establish that pipeline, you know, the road and really afraid to get them to the kind of things people for you on the benefit. The bill does a lot of interesting things for us from a perspective of he makes sure that survey so when there's a problem, you definitely let them know. They've been very supportive. I think in the last couple of years, races have gotten more support. They had the previous year. And then that's bad on us because we should realize the capabilities and then for our force to make sure that we got things better. We had to move and instead of going about it, we also see on
Dover Road.
Dover.
Yes.
We're really excited about that positive facility. Now everybody wants their own little thing on the power on that. That was good. A great good element is the great. You gotta have a room inside there too, where it's a council. that one hundred twenty, to do that all in the community. The dedicated space and races in there. We have an exercise coming up for the day where we have to, down out here and go in kind of the region state. So, you know, they didn't have for there, we got the crew. Well, they'll come down here. So he'll go down to the four sites, for us. Maybe problem. This one down here, top road. What do you mean? They get us out of here. Even though this road, we operate there. We operate here. You know, so there's usually this part of that. Then if it comes to them, then you guys have to get out of that. And Brian explains that to a lot of people that they not always be there. They will do it. So he'll normally explain that for us, and he puts his filter on that. And even if I go to my dog, he's working to handle that. But I tell you one thing, I enjoyed you guys. We had fun. I appreciate the shirt that you guys gave me, and for coming to the Tim is a bit ladies all over the place. Anytime we have outreach and stuff like that, you guys will come out and participate. We got a big event out at USF
Next Saturday.
So then we split outs because we have something in the school. We'll be giving out resources and stuff like that. Some food items and things like that. From our perspective, we'll hand out literature and little swag bags and stuff that weather video, stuff like that. So you're more than welcome to move your outreach, join us, and then you bring stuff out, you know, and that way you can reach out and try to affect them to come and try to get attention. You know, that's the only way to do it. They're there. They just talking to do it on their own. They don't know about you guys a club and organization. So we got to make sure that we spread the word, and I'll talk to them about doing point class, you know, for the county, and then that can probably everybody just put the meeting. Appreciate you. Thank you.
Well, go ahead, Bill.
So yeah, we're going to join OEM next Saturday over at the USF. We're going to take some of our stuff. There are times when we go out and we do the outreach for OEM, so we only have Racy's members there. But next week we're going to have both Hillsborough OEM and Racy's there, and we're going to be focusing on recruiting more so while they answer the disaster preparedness. And that's one thing that this county is really pushing. We're not talking hurricane preparedness. We're talking disaster preparedness, all incident. Because if you drive around Hillsborough County, you probably can't go a mile or two without seeing trucks pulling hazmat or crossing a underground pipeline with hazmat. And I really think we're going to get a hazmat issue before we get a hurricane here. So that's the way we go. With that, I'll turn it over to Daryl's your name, isn't it?
Yeah.
Good morning, everybody.
That's what my name tag says. Very valid points this morning, very valid, that we prepare for more than just hurricanes. It would scare the public if they knew average what ran up and down the roads every day. They wouldn't drive. We know what it is, but then so we need to be prepared for more than just that. Recently, we had a little tabletop exercise with our during our Christmas party with the school board. They said we had a cyber attack and turned off the internet. What do you do now? And Kyle and I are there at the Christmas, and our Aries hat turns on. We start thinking, you know, we're thinking, and I'm getting this is segueing into you. I could talk to Kyle on NXDN and Bartow through the NXDN Bartow repeater. And we had communications. And so we did that. And I said, hey, and we actually demonstrated the other day. A fiber got cut here in Brandon. Did it make the news? The fiber cut here in Brandon for Frontier and Spectrum. It took the entire Polk County School Board down. Took it all. It was in the news, I'm sure, by now. And Kyle and I got on NXDN in case we had an emergency. Because when your internet goes down, guess what goes down with it? Your phones, your intercoms can go down. A lot of things go down. And so we had to think outside the box. And speaking of NXDN, now I'm going to introduce the 9 o'clock programs. And by the way, is the room here in the back, this room where the second track's going to be, the one room right behind us, where it has been, okay? Now, if you turn there's 2 doors, you can get in the room to either one of those doors. That's where track number 2 will be. It is being recorded. So that way you can go back and watch it later. It's also going to be 1 continuous or 2 recordings. Pause it to save on space. And then Russ in 4RTD has generously agreed to edit these videos. Okay, the 9 o'clock programs will be, you got 2 really fantastic choices. I get my smartphone here. I should have printed it out and it didn't. We're going to be doing in this room all about NXDN and Paul NB9X. Paul Toth is going to be doing that one. And the Gordon Gibby KX4Z is doing the Alachua County quintuplexer. I'll get it right in a minute. So that's an interesting deal. So if you go to one, miss the other, you'll be able to catch the videos in a few weeks when Russ gets them all done. So Paul, I'm going to turn it over to you, and the time and the microphone is yours.
Thank you, Daryl. And I presume this can be clipped on here someplace. So let me just, let me take care of that. And as you'll see, I'm all thumbs. I think I've got that on there. Well, good morning, everyone. And let me turn this on so that for those of you who may be closer to the back of the room, things will not be quite as difficult. You won't have to strain to hear me. Welcome to the 10th annual TechCon. Daryl, thank you for the introduction there. We're going to be talking all about NXDN in just a moment, but I would be remiss as the president of the West Central Florida group, which has brought forth the NI4CE repeater system and has, well, it was our creation to begin with. We have kept it going. And I think it only fitting that on this day, when we talk about things technical, that we also have a celebration, because today is the 23rd anniversary of NI4CE going on the air for the first time from our Verna site in Manatee County. It was 4:52 in the afternoon when we turned 145.43 on for the very first time. And 23 years later, we're still going strong. We've expanded the system just a little bit. We've gone from 1 site and 2 repeaters to, well, you'll see how many sites here in just a moment, because in addition to the analog repeaters on VHF and UHF, we also have a very broad NXDN network that continues to grow because the users of NXDN continue to grow with it. It is a reflection of how this new digital mode is being used, how it can be used. And as Daryl mentioned a moment ago, when the internet goes down, a lot of people just, you know, their hair stands up, they freak out, they don't know what to do, because the internet is tied with everything. And if you lose the internet in this day and age, you may end up losing a lot of your capability if you haven't thought about contingency plans. So a very happy 23rd birthday to NI4CE and the West Central Florida Group Incorporated. We will continue moving forward as we continue on here in the 21st century and continue making ham radio relevant and modern for everybody, not only in this room, but everybody in West Central Florida. With that, we're going to talk a little bit about NXDN. And as Daryl mentioned, this is going to be kind of an update, but we're also going to be talking about some new things that we're going to be bringing to the forefront with NXDN. And as a preview, for those of you who may have thought about doing something else for our afternoon track starting at 1:30, you're not going to want to miss something that we are going to be premiering this afternoon during that track. We'll talk a little bit more about that in a moment. Yes, Bill.
Also, in the NI4CE repeater system, one of the repeaters that they were taking down and moving them, they made it available to the Hillsborough County area's races. And this is a huge tent stake in the ground for us to build off of, because that one repeater at 800 and some feet, we've got HT coverage across the whole county with that. So instead of having very complicated net controls and 205 and stuff, it made it very simplistic, and that gives us better use of our human resources to put out there where we need them. And to that, we thank Paul and I4CE. This is his idea he brought to us. So I think it's a good one, and we appreciate that, Paul.
Bill, our pleasure. And we have a situation where this particular site, which is here in Hillsborough County, covers not only the county, but if Bill somehow needs to reach out to his counterparts in Pinellas or Polk or Pasco or Manatee, yeah, the repeater goes that far. So it is a win-win for everybody. And again, just to go forward with our commitment, that repeater also happens to be on a very large generator, so that when the lights go out, as they have several times at that particular site, commercial power is what it is. Generator is there, it kicks it on, it keeps it running. So we're very happy to work with Hillsborough County on this and provide service that is otherwise somewhat limited here in the county. Now, NXDN started out actually with the first repeater at that particular site. It is the ATC Riverview site down on Rodine Road. Since that time, as you can see from the map, we've expanded just a little bit. And very recently, we added our newest repeater to the network, that down at Babcock Ranch Village in south central Charlotte County. The new repeater there on 442.5125 enhances the coverage in Charlotte County, but more importantly, in a community that is one of these that has grown out of the middle of a pasture, namely the Babcock Ranch Reserve, into a 50,000 population planned community. The folks there, when we have a disaster, when we have the next hurricane, will have portable handheld coverage inside their well-constructed buildings. They had coverage already from our Charlotte South site, but once you go inside many of our new modern buildings that are, built like Faraday cages, you've got to be up close and personal with the repeater in order to get out with a handheld. Well, they now have that. In addition, going from the south extreme to the north extreme, our Villages Sumter County repeater up there at the very top of the map will be going up on its permanent tower location, also with emergency power, in the very near future. Construction got delayed just a little bit, but I look forward to seeing that particular repeater on the air at its permanent site. And that particular repeater will cover most of Sumter County. It will get into Lake County to the east, Citrus County to the west, and Marion County to the north. And one of our motivations for that particular repeater, given the fact that NI4CE also supports the National Weather Service Skywarn program, is that the Villages is a very unique situation related to weather service and severe weather coverage. What most of you probably don't realize is that the Sumter County part of the Villages gets their warnings from the National Weather Service in Ruskin. The Lake County section of the Villages gets their warnings from the National Weather Service in Melbourne. And the Marion County section of the Villages gets their warnings from the National Weather Service office in Jacksonville. The Villages was literally built at the convergence of 3 National Weather Service county warning areas, which makes trying to sort severe weather out, which knows no political boundaries, somewhat difficult. With NXDN, we're able to connect the Skywarn coordinator up there with any office that he needs to be connected with. And that in and of itself is also unique. We've built this system because we believe NXDN is the future for ham radio. Of all of the digital modes that are out there, NXDN is the closest thing, by virtue of its FDMA modulation, to what we currently experience on analog. It is the clearest, the least complicated of all of the digital modulation modes. And because it is a full-time modulation mode, you're not doing a timeshare like you do with TDMA. It just works. And the other great benefit, as you've heard me talk about for the last several years, is that NXDN, even though it uses 1/4 of the bandwidth of our typical wideband 25 kilohertz channels, NXDN actually has a better coverage footprint and operates at a lower signal strength than our 25 kilohertz analog modes. It is a win-win-win situation, and the equipment has been around a while, since 2005. We're already on the 2nd generation, and I have it on good authority from some friends of mine at ICOM that a 3rd generation radio is in the works. So NXDN is around, it's been around, it's getting better. What is it? Well, as we said a moment ago, it's 6.25 kilohertz ultra narrowband. So for every 25 kilohertz channel that we take up with an analog signal, we can actually put 4 NXDN signals into that same amount of bandwidth. Why is that important? Well, as our population continues to expand, more people want communications. And as more people want communications, we have to be able to provide those lanes of communications. You know, just as our 1-lane roads have turned into 4-lane and 6-lane and 8-lane, and in some places 10 and 12 lanes, well, we've got to be able to do the same thing with our radio resources. As I said a moment ago, it uses FDMA modulation, which is the closest thing to what we've all come to know and love and embrace in the analog world. And that makes for very easy to understand audio modulation with some extra benefits, because remember, this is digital. And if it's digital, yes, you can do data. The weak signal performance, you can't get any better than this. At minus 116 dBm, which is what these radios are guaranteed to be able to demodulate. If you were listening to this on analog, it would be mostly noise. It would be unintelligible in most cases. So when the message needs to get through, be it voice or data or GPS positioning, NXDN gets the job done. As I said a moment ago, the 1st generation radios have been around since 2005. And what was the genesis for NXDN? Well, the FCC put out a report and order in December 2004 that said, this is what we want ultra narrowband digital radio to be. Their concept was 6.25 kilohertz, FDMA modulation, and a data rate of 4,800 baud. Doesn't get any more complicated than that. NXDN evolved because two major radio manufacturers, ICOM and Kenwood, said, okay, we're going to take this and we'll see if we can come up with something. And in fact, they had already been in the laboratory working on it. You know how those mad scientists are. And in fact, NXDN is 6.25 kilohertz, FDMA modulation, data rate of 4,800 baud, be it voice or data. So it hit the mark. The second generation radios have been around now for 9 years. It's been that long. The second generation radios brought with them some additional features. One of them is over-the-air alias, which for all of us in this room, and for those of you out there watching on YouTube, that's a godsend. Because if you look at Part 97 and the rules, it states you must identify your station at least every 10 minutes. With over-the-air alias on NXDN, you have the opportunity to identify your station every time you press the push to talk. It's that simple. You put your call sign into the over-the-air alias text field in the programming, and when you press push to talk, that over-the-air alias is automatically transmitted as part of the stream. You identify your station every single time. One of the other things that also was an improvement with the second generation radios was the ability to selectively scan the RF frequency that you were on for multiple talk groups. One of the really neat things with NXDN is you can segmentize the traffic that flows over that RF carrier. Now, here in Florida, and we'll get into this in just a moment with greater clarity, we have set up on the NXDN network multiple talk groups. Think of it this way. In the analog world, we use 146.52 and 446 straight up as call channels. So if you want to call somebody, you do it on those two frequencies, particularly if you're operating in a non-repeated mode. In a repeated mode, you just simply throw your call out there, you call for somebody, hopefully they come back. Well, in the NXDN world, we may have several different things going on at the same time. It is not a one-size-fits-all. We may have some traffic going on talk group 1200, which effectively becomes the call channel or the call talk group for NXDN here in Florida. In other parts of the country, it's likely going to be something else. But here in Florida, it's talk group 1200. But if you're in Charlotte County, as an example, and they have something going on in Charlotte County, and now that they have 3 repeaters, you're more than likely going to hear that traffic on talk group 1215. And there may be some other event going on, such as the emergency exercise that took place last weekend in Manatee and Sarasota County, that used not only talk group 1200, but also used talk group 1231, which is a tactical talk group that we've set up in the big scheme of things so that we can segmentize that traffic, put it off over here so it's not bothering folks where they don't have an emergency going on, or they may have their own emergency going on, and we have 3 other tactical talk groups that they can potentially use. One of the other things that we're still working on, and we have a mad scientist in the name of Tom Chance, K9XV, who is writing the code for this, because NXDN also supports GPS for automatic vehicle location, or in the case of an emergency exercise or the real thing like we had last weekend, automatic personnel location, APL. We'll soon, in the near future, be able to take your GPS traffic that you've generated on NXDN on talk group 14439. And for those of you who know anything about APRS, you know, it's just one of those natural things, but GPS traffic will be routed on talk group 14439. And once it is captured by NX Core, it will then be rerouted to APRS served. And of course, it's no accident that the NI4CE system has APRS digipeaters at all of our analog sites, so that if you're on APRS on the analog side, you'll be able to see that GPS traffic coming from NXDN. Pretty cool. Now, we've talked about some of the things that are part of NXDN. We have two different modes. We've got conventional mode and we've got trunking mode. The trunking mode, we're not using in amateur radio. Conventional mode is getting it done very nicely. And because we're doing everything that we're doing on the network in conventional mode, we've got significant interoperability between the equipment manufacturers. So it doesn't make any difference whether you have a Kenwood radio or an ICOM radio like this one, or a Kenwood radio. Both of them interoperate in conventional mode with voice traffic. And even though all of our repeaters happen to be ICOM, for reasons I'm not going to get into, but it works, and we went down that road, so hey, we're there. If you've got an ICOM radio, you get into the repeater just fine. If you've got a Kenwood radio, you get into that repeater just fine. And there are a couple of other manufacturers, primarily with specialty NXDN products, that are out there manufacturing, and their radios work in conventional mode just fine. Now, there are a couple of proprietary things out there related to NXDN, because for whatever reason, ICOM and Kenwood, who are the two main players, just decided to go off on their own direction. Things like text messaging and GPS are handled a little bit differently depending upon who the manufacturer is. We're working to try and bring that together on the network, so if you've got a Kenwood and you send a message, that it will somehow come out on the ICOM radios and vice versa. At the moment, it doesn't, but we're continuing to work on it. People ask, well, where can I find an NXDN radio? Because you go online and you go to your favorite ham radio store, whatever that may be. It may be Ham Radio Outlet, it may be Gigaparts, it may be DX Engineering, or it could be, you know, somebody that I haven't mentioned here. And you're going NXDN and they, you know, you get the deer in the headlights look. Well, for whatever reason, good, bad, or indifferent, when NXDN was introduced, it was created, first of all, as a Part 90 land mobile radio product. You know, those are the guys who, you know, have the licenses between 450 and 470, or in certain markets, 450 to 512. And Kenwood and ICOM decided we're not going to introduce NXDN into the amateur radio market, in part because, you know, ICOM already had D-Star out there, and so did Kenwood. So this would potentially be a conflict in a competition. The bottom line is, if you want to buy an NXDN radio, if you want to get involved with this very exciting, forward-looking mode, you have to find a land mobile radio dealer to purchase it from. There are many. And as a disclaimer, yeah, my day job is as an ICOM land mobile radio dealer. There's the disclaimer. But the bottom line is, if you want to buy, you've got to buy, not necessarily from me. You can buy it from any ICOM dealer, any Kenwood dealer. And with the internet, they're not that hard to find. Will the traditional amateur radio retailers ever have NXDN? I think at some point, ICOM and Kenwood will take the wraps off of that limitation. I don't know when it's going to be, if it'll be in the next year, the next 2 years, the next 5 years. But as NXDN grows in the amateur radio marketplace, I think they will do it. Now, when we talk about amateur versus land mobile radio, the amateur radio market, you've got amateur radio frequencies only, whereas land mobile's got the entire amateur radio band when you look at the hardware. If I take this radio right here, this radio will do the entire amateur radio band, 420 to 450. It will do the entire land mobile radio band, 450 to 470. And embedded within that land mobile radio set of frequencies, you also have GMRS and FRS. So if you've got a radio that only does ham frequencies versus a radio that does a whole bunch of other stuff that is now coming into play with a lot of emergency communications paradigms and protocols, which radio would you rather have? Technical support? Well, there's technical support all over the place for both ham radio only radios as well as land mobile. And in fact, I can tell you from having done it that if you call ICOM Tech support, those guys handle the whole scheme of things. And at ICOM, their marketplace is not only amateur radio and land mobile, it's also marine and aviation. So the folks there are really well versed in all things radio. Want to bring this up, and this is an appropriate time since it's up on the screen. In the land mobile radio marketplace, you've got really two different sets of bands. As I mentioned, this radio right here will do 400 to 470 megahertz. Okay. There is a version of that radio, and most land mobile radios that do 450 to 512. And that's because in the scheme of things, there are some markets around the country, Miami, Atlanta, Chicago, New York, Washington, Dallas, the big cities on the West Coast, where there's this animal called T-band. What is T-band? Well, here in the Tampa Bay market, we have television stations between channels 14 and channels 20. You go to Miami, you will not find a television station on any of those channels because it is reserved for land mobile radio. Remember, we said a moment ago that the FCC was trying to figure out a way to squeeze more stuff into the bandwidth? Well, in Miami, it came squirting out both sides, and they said, we can't get everything that we need in that 20 megahertz of bandwidth for land mobile radio. So they still have T-band, which operates 470 to 512 megahertz. As a result, the manufacturers have a low split radio and a high split radio. Here's why this is important to all of us as hams. There are these radios out there, and the common denominator for a high split and a low split is that 450 to 470 part of the band, where the radios were originally manufactured to work in. Now, the low split radios will do the amateur radio band all day, every day. The high split radios, not so much. And in fact, if you put a programming profile that has, let's say, a ham frequency of 442.5125 into a high split radio, and you turn the radio on, the radio is going to sit there and blink at you, because it's trying to tell you, you've got a frequency in here that I don't know how to deal with. Now, this is important because if you go out on the internet and look at the used radio market, you're going to find some radios out there that are high split. And when they're put out there, that's not necessarily something that is advertised. So be very careful if you're buying an NXDN radio, or for that matter, any land mobile radio that you want to have work in the ham band. Make sure that it in fact is a low split 400 to 470 megahertz radio. Otherwise, you're going to have a radio that'll be sitting there blinking at you. Now, there is, and thank goodness there is, a departure from this. ICOM's latest radio, the F5130 in the VHF band and the 6130 in the UHF band, are what are called all band radios. So on the VHF side, it's 136 to 174. On the UHF side, this radio will operate 400 to 512. And there is some circuitry in the radio that if you, as an example, were to put in some ham frequencies, some GMRS, maybe even a T-band frequency, the radio knows how to deal with it. It will operate over the entire band. That is a major step forward and a major simplification for the manufacturing folks, because now they don't have to worry about designing two radios. They just simply design one. If you are going to be operating, and many of us are involved with emergency communications, if you're going to be operating in the ham band and the GMRS band, FRS, land mobile, make sure that your antenna is capable of operating safely and efficiently over that spread of frequencies. If you have a fiberglass antenna, chances are it's not going to be able to do that. Fiberglass antennas tend to be cut for no more than about 6 megahertz of usable, efficient frequency space. So if it's a fiberglass antenna that's cut for the ham band, you're probably going to have very mixed or unacceptable results if you all of a sudden turn your radio over to a GMRS frequency. What's going to happen? Well, in most cases, what ends up happening is because the antenna is out of tune with the frequency that you're transmitting on, it's going to cause a high SWR, high reflected power, because it's not resonant. What happens when you have high SWR coming back at your radio? Well, if you thought your radio was warm when it was operating on a frequency that the antenna was built for, it's going to get a lot hotter. And what will end up happening is you'll end up effectively burning up the power amplification chip in the radio. Now, ICOM and Kenwood both have circuitry in their radios so that if the radio detects a lot of reflected power coming back, it tends to knock the power down so that even if you've got the radio set for 45 watts, you may not get more than 5 watts out of it, which may also be very unacceptable in terms of trying to reach the person or persons that you're trying to reach. So there is what's called a fold-back circuit in most of these radios. But nevertheless, even with the fold back circuit, sooner or later, you are going to toast your radio. And I'll tell you, in order to get the power chip replaced, which requires a lot of delicate equipment and some skill, you're probably going to pay about $300 to get it done. So it's not an inexpensive proposition. What's a good wideband UHF antenna? Well, you've heard me talk about the MP antenna porcupine, which is my term for it. It's not theirs, but it's got 3 elements on it at 120 degrees separation. Each of those elements is a slightly different length, but the antenna is designed to work 400 to 500 megahertz. It operates with a minimal amount of reflected power, and because it is a multi-polarized design, it deals very effectively with bit error rate. And in fact, in testing that was done independently, in fact, right about the same time, back in 2007, MP went out, they tested this antenna, and they saw some significant improvements in bit error rate because the antenna knows how to deal with reflected signals. And you know, every time a signal is reflected, it changes phase 90 degrees. Have it reflect twice before it gets to your radio, and what are you doing? Well, you're killing your signal. At the time when MP was doing this independent testing on their own product, the West Central Florida group did something rather bold and daring. And because our good friend, who unfortunately is now a silent key, Ed Allen, WA4ISB, God love him, Ed was Mr. Broadcast Extraordinaire. And at that time, had a working relationship with the largest antenna manufacturer in the world for FM and television antennas, Dielectric. Ed was able to convince the folks at Dielectric to bail out of Maine for 3 days, which is where their headquarters are located. They came to Tampa, and we did 3 days of field testing with a circularly polarized antenna. When all of the signals were captured, when all of the data was analyzed, we found out that the results that we got with a CP antenna at the transmitter were virtually identical to the results that the folks at MP got with the porcupine, both in terms of gain and in terms of the ability of the antenna to deal with bit error rate. So even though there are only a couple of land mobile radio manufacturers out there producing circularly polarized antennas, you can effectively have and gain the effects of a CP antenna on your digital communications with the MP porcupine. And if anybody wants more information about that, come see me after the presentation. And in fact, if you've never seen it, there's one sitting on top of my car. It's been there for several years. I wouldn't be without it. Couple of operating things that we've talked about. And we talk about this on the air during our NXDN net every Wednesday night on Talk Group 1200, 7:30. Be there or be square. Although I do understand that there are a number of folks here on Wednesday nights that can't make it because they're in church. And I'm the last guy that will try and compete with a God net. So no problems. But one of the things that we have learned, because there are multiple talk groups on the network, is when you throw your call sign out, also mention which talk group you're on. Because again, the radios have the ability to monitor multiple talk groups simultaneously. And my radio might be on 1200, your radio might be on 1299, which is our Skywarn talk group. Or it might be on 1215 if you're down in Charlotte County. Or it might be on one of these other tactical frequencies. Or it might be on talk group 1, which a number of you I know use on a daily basis because you're able to keep your communications local. So announce your talk group. NB9X, talk group 1200. Or KT4WX, talk group 1. Unless Daryl hasn't looked at his radio and he's still on 1200. Sorry, Daryl, I had to tweak you there. Talk group 1. Here's how it works. It's real simple. If you're on using a particular repeater, let's say it's the Boyette repeater, which is right down the street, and I'm trying to talk with Ken. Ken's on the Boyette repeater, and I can be on the Boyette repeater, and we don't want to tie up the rest of the network. We just go to talk group 1, and the only repeater at that point that is active is Boyette. And at the same time, while Ken and I are on Boyette, Daryl and Kyle over here may be on Bartow on talk group 1. The beauty of NXDN is that it is not a one size fits all. It's not like analog. We have a great deal of granularity that is possible, and something that really can serve all of us very well. We just have to be a little bit careful of how we use it. People ask me, well, when are you going to turn the NI4CE NXDN repeater network over so we can put and use it with our hotspots? At one time, the repeaters, when the network was a bit smaller, did in fact make itself available for hotspots. But we ran into some problems with that, because when you're connected on a very large network that actually goes well beyond Florida, in fact, it can go worldwide, you might have some folks in Missouri or Germany or Wisconsin or Indiana that are using talk group 1200 because they think, well, it's available, I'll use it, not realizing that they're bringing up a repeater network in Florida and maybe a few other places as well. Unfortunately, we had to sever that connection because in a couple of cases, it got in the way of emergency communications that needed to happen here. The NI4CE network is a radio over IP network. It is not voice over IP, which is what hotspots are. Now, we are working on a way of trying to bring the hotspots back for people here in West Central Florida. Be listening for an announcement on that in the near future. We talked before about our granularity. Talk group 1200, it's kind of like a calling talk group. It brings up all of the repeaters at once. However, if we've got something going on here in West Central Florida, because, you know, now we've got a repeater up in the Villages, we've got repeaters in Melbourne and down on Sanibel Island, Lee County, we cover portions of all 3 sections in Florida. We might have something going on that is West Central Florida centric. So at that point, if we need a general calling talk group, it'll be 1201, which in your radios is listed with a W. We mentioned 1215, which encompasses parts of Sarasota, DeSoto, Charlotte, and Lee County. 1230 through 1233 are other tactical talk groups. And in more recent days, we have also now opened up talk group 1299 for Skywarn. Yes, our National Weather Service office in Ruskin is outfitted with an NXDN radio at WX4TBW, the ham station at the Weather Service forecast office in Ruskin. And because we now have the ability to bring in Skywarn traffic from the north and from the south, because the network now reaches into those areas, we've put this up on Talk Group 1299. So it keeps the traffic off of 1200, makes it very specific for Skywarn. And the one other thing that we're still working on, which I hope we'll have in place in the next month or two, is that for certain Skywarn operations where we have things going on both NXDN digital and on NI4CE analog, that we will be able to combine those two networks together, particularly for our nets on Tuesday night. Future improvements. One of the things that all of your NXDN radios have is a capability called vote scan. You know how with your cell phone, you just dial a number, and with all of the new towers that have been put up in the last 5 years, your phone call continues to work even though the range of a particular cell tower usually isn't more than 2 miles. The radio just kind of figures out that if I need to jump from this tower to this tower, that it will do it. Well, vote scan is the same concept. In fact, it's not only the same concept, it's the same technology. Vote scan is a capability within your radio that reads the signal strength of the tower you're on, but also looks around to see if there are other towers that it can hear. And if the signal strength from another tower is stronger, it just automatically switches. It channel steers your radio automatically. So once you turn it on, you don't have to touch it again to change channels. We can now do this because we've got a more robust infrastructure. If you're mobile, there's virtually nowhere that you'll go in West Central Florida and not be within the reach of at least one of the NXDN repeaters. And in fact, if you're driving up US 17 through Charlotte, DeSoto, Hardy, Polk County, you've got overlap signals to beat the band. We talked about GPS coming in on NXDN, being ported to APRS. We're actively working on that. Finally, before I close this session, because we're running a little bit long, for those of you who are available this afternoon at 1:30 for our afternoon session, you are going to be in for a treat. We've talked about using NXDN for voice, but we've also said in our presentations that NXDN has a messaging capability. This afternoon, you will see the debut of WX Message for NXDN. This is a keyboard messaging program that works with ICOM radios that will enable you to send messages of up to 90 characters, because we need 10 characters for overhead. But this will enable you to send text messages of a general nature. But we call the app WX Message, as in weather message, because we've got some hooks in there for Skywarn, something near and dear to my heart. So if you can join us this afternoon, we are going to give you a live computer to computer, radio to radio demonstration live on the air. And for those of you who have your NXDN radio with you, we'll be operating this afternoon on one of our simplex frequencies because, Bill, unfortunately, your building here is a Faraday cage. So we're going to be operating simplex. And if you turn your radio to direct 1, that's the frequency we'll be using. And you'll actually be able to read all of the messages that we're going to be transmitting from our computers back and forth. So come join us at 1:30. and you will get to see the public outing, if you will, for NXDN messaging, weather message for NXDN.
There's questions on the chat that have been posted. You may read those and answer them.
All right, let's see.
Right here in the chat.
All right,
We have
and
two questions.
in the chat portion, it says, is there a mechanism to prevent or hold off talk group 1200 traffic on a single repeater when that repeater is occupied with talk group 1?
The answer is yes. In fact, that is something that our mad scientist programmer, Tom Chance, K9XV, is not only working on with talk group 1, but also all of the talk groups. Because if, let's say in Charlotte County, they're on 1215, they don't want to hear talk group 1200 traffic either. So yes, it is, it's still being tweaked a little bit, but so far the tweaks have been working. And in fact, this last Wednesday evening, because of how this works, we actually had to hold off on starting our NXDN net at 7:30 because the traffic on 1215 from a Charlotte County NXDN net ran just a little bit long.
Another question here. Is ICOM planning to release a small NXDN HT that can be programmed with a USB-C cable?
I have it on some pretty good authority that the 3rd generation radio that ICOM is working on will incorporate USB-C, which is the same technology that is now in most of your smartphones. So look for that to come. I don't know when this 3rd generation radio is going to be released. I know that the engineering folks in Japan are working on it. Now, will it be a small radio? That I can't tell you. But this was a 1st generation radio, rather large. They've shrunk the radio down to this. This is the ICOM F62D, and it's a great little radio. A little bit pricey, but it is a great radio and a great, great set of ears. Say again?
5 watts.
All of the portables are 5 watts. And in fact, they're not just 5 watts, they're 5, 2, and 1 programmable, which is a really significant thing to mention, because if you're trying to do any of the new 2-watt FRS frequencies, you can actually program the radio down to 2 watts. So, anyone in here have any questions? Yes.
Just when I think I have enough ham radio equipment, you show up.
What can I tell you? Yes, Bill.
To your point about the Faraday cage, I'm looking for a WCFTECHCON EVA. What's that mean?
Okay. We'll talk offline. All righty. Yes, sir. Absolutely, you need a license. I mean, if you're going to operate on a ham frequency, it doesn't make any difference whether it's analog, digital, whatever. You've got to have a ham radio license. If you're going to operate GMRS, you need a license. They're not hard to get. Yes. If we go back, unfortunately, I don't think I can go back here readily, but let me see if I can bring the slide back up again. Stand by. exactly. Let me also just share one other thing. In the scheme of things, you know, we have in the world all kinds of acronyms, RACES, ARES. You're hearing a new one called Auxcom, not Oxcom, Auxcom. Here you have ham radio operators as well as others that are also being given the latitude, if they have the equipment, to be able to operate on Part 90 frequencies, because their local government agency says, yes, we want you to be able to operate. Well, with one of these radios, and in fact, this happened during Hurricane Ian in Charlotte County. The hams that are part of the CC Flares group down there not only operated on their amateur frequencies, but they also have programmed into their radios the NXDN frequencies for the Charlotte County Public Schools, which operated a number of emergency shelters. And they also have an emergency management repeater frequency, which is on 453 something or other in Part 90, that they will be given latitude to operate on as well. And they don't only have to carry around one radio. When you ask about the frequencies, these are all of the frequencies that are part of the NI4CE NXDN network. And if you haven't got a camera to capture that, go to ni4ce.org. In the upper left-hand corner, there's a little multi-line box. Click on that and go to NXDN. That's the map that's on the website.
These slides will be up either later today or tomorrow on the TechCon page as well.
All right.
So they can go download it and review it.
Absolutely. And for all things NXDN, go to the NI4CE website, because we've got lots of information out there. A lot of the information you saw on the slides today are out there for full-time consumption. And if you have any questions, we had my email address up there, but it's real easy to remember, nb9x@ni4ce.org. Yes, sir.
ICOM also makes D-Star. What's going on in the D-Star world? Is that sort of, kind of the past history, or are they also expanding and doing great things?
D-Star is an old technology. It's been around since the early to mid 90s. And while ICOM is still manufacturing and selling D-Star radios, they are for the most part just incorporating D-Star into other existing platforms, not coming out with specific D-Star only radios anymore. And I don't have any insight as to how long D-Star will continue, but NXDN, I think, will overtake it.
Stop the production of the Gen 2 repeater and dump them on the family of the house. So the 100% production on the Gen 3 requirement. One of the things that popped up when we were doing this is like the NXDN radio, we think that these talk about people that don't swap back and forth between modes based on what the input is. So
Well, and in fact, here's a dirty little secret. The repeaters that we have in place for NXDN are all ICOM. They're either FR6000 or FR6300 repeaters. Those repeaters will ingest and put back out an analog signal if it's analog, and if we programmed it that way, or it'll be able to do analog and NXDN or NXDN only. The repeaters you see up there on the map right now are NXDN only, because they operate at 6.25 kilohertz, and that's our bandwidth limitation. But the repeaters are capable of operating both ways. And here's the dirty little secret. If you want to put up an analog repeater and you want to buy a brand new ICOM repeater to operate that frequency on, you're buying a land mobile radio repeater, because ICOM does not manufacture an analog ham radio only repeater. And the good news is ICOM also, even though on Part 90, they've got to limit the bandwidth on analog to 12.5 kilohertz. They've had to do that for 11 years. But if you're buying it for ham radio, we can buy it all day for a 25 kilohertz operation. So with that, thank you all very much. I think I've run over my time here just a little bit, but come join us at 1:30 and you get to see the debut of Weather Message for NXDN, which, by the way, since we have an F6400D at the Weather Service office in Ruskin, when the internet decides to break, this will be our backstop for NWS chat. Thank you.
Thank you very much. All right. Well, at least I got a video back up here. Okay, just, oh, yes, thank you. We need that for the stream. I got two microphones. I'm in stereo. All right, just a heads up that if you want to have join the pizza at noon, which will be here in the dining hall here, you could chip in your $5, whatever now. Is there someone that would go ahead and be willing to take that up and somehow could facilitate that being ordered? So we'll have it at noontime. If we could, we would really appreciate that. Someone would facilitate that. So look for that during this time slot. And now, without further ado, we're going to go ahead and get into our next presentation. We only have one in this track. We have Gordon Gibby again, KX4Z. He's on overdrive today. He's doing 5 presentations, and he's going to do an update now on the massive improvements in the BitX radio. Massive improvements in the bit, and he's got, matter of fact, I brought mine with me if he needed it for whatever. So you can feel free to use that if you need it. He's going to set up right now. Yes, sir. Okay. Okay. Housekeeping notes here. Food stays in the kitchen only, if you would, please. I presume a mint, or is there maybe an exception to that, as long as you don't make a mess with a mint? I'm talking about like M&Ms. I meant not M&Ms, pardon me. Lifesavers. We have some Lifesavers, little chocolate candies back there you can have after you have your pizza, so you can get rid of the pizza taste out of your mouth. And if it's a drink in here, just have a lid on it, if you would, please. One of those doubly insulated mugs come in real handy. I've even got mine in my basket there. So, and no food in here in the operations room, please. We want to thank, I have not done so now. I want to again thank Hillsborough County Emergency Management for the use of the Public Safety Operations Complex. It's a wonderful facility that will be improved. They're looking at doing some technology improvements for meetings and so forth. So, Gordon, do you want me to bring up this slide presentation? Okay, I'll bring yours up now, sir. And we will close that. All right, let's go ahead and go here. So I know it's on my flash drive here. We'll have that up momentarily. There it is, my flash drive. And bring up the, let me move that over a little bit. Okay. Oh, there it is. Yeah, there we are. And there we go. Massive improved SBitX. He's going to show you his, but and you can see it there. I like the wallpaper they have on it, but I'm not going to steal any of your thunder. I'm going to hand these mics to you, and you can clip this one on and hold this one for audio, and the presentation is yours.
So this is all I need? Oh,
That's for the stream.
Oh.
That's for the inside of the room.
got it. I think I can do 2 things at once.
I'm challenged for that too, Desmond.
All right, here we go. Okay. Looks like this works. Cool. Okay, so last year we were kind of discouraged when I spoke about the SBitX. It had huge spurs, 500 kilohertz multiples off of the 80-meter signal. The purity was sort of questionable everywhere else. and I had managed to blow up 2 Raspberry Pi 4s, and at that time their price was unobtainable. So for about 6 months, there was just nothing I could do. And I was kind of a little irritated by that because the power supply, the DC power supply in the system was creating havoc, and my attempts to replace it, I couldn't even figure out what I'd done wrong. The voltage looked fine, but the raspberries were toast. And I tried all kinds of things because I'm not really a raspberry guru, but I tried reflashing and I tried all these rewritings and nothing worked. So we were kind of toast. So we're going to give you a little review before we go forward. The picture on the right, I think, is a development edition. I've got one of those also. I forget the number. I think my development edition is number 26. It's an SDR architecture. The software-defined radio is done in a Raspberry Pi 4, but I'm told it will work in a 2W or it will work in a 3B. So basically, it doesn't need a whole lot of computer to do it. All the modulation, demodulation is done in mathematics instead of in diodes. Heterodyning is done in diodes, but modulation, demodulation, if you can write the routine, you can do it. Raspberry Pi 4 processor touchscreen. You can see the touchscreen here. FT8 was built in. Asher is in India, and his goal seems to be building a self-contained radio that you don't need a spare computer to operate. So that doesn't always fit with what I need, but that was his goal. PSK31 was built in. His original devices were sort of 40 watts in the lower bands, and he's not the greatest RF designer. So his power kind of twiddles off to about 10 watts on 10 meters, and that doesn't bother him because the D layer is just non-existent at 10 meters. So if the band's open, 10 watts is good. And a lot of people criticize and they wanted, a flat amplifier, and he just doesn't care, right? It's a different way of looking at life. Digital filtering, and that's one of the features that I thought was the most astonishing. It was so much easier to set bandwidths on an SBitX than on an ICOM 7300. In fact, to this day, I can't really set my 7300 really very easily at all. But on this thing, it's just a cinch. So I'm going to go briefly on. I need my, gotta get my pointer. I got to go briefly over how the architecture of this thing works, because this is a budget device. This is not ICOM price class. It is a very simple device. So there's the transmitter side there, receiver side coming backwards. He's got a mixer here, another mixer here. He generates his signal in ultrasound frequencies at about 24, 25 kilohertz. He has a bandwidth of his IF from 0 to 50 kilohertz, 48, I think, actually. Everything is done with stereo audio file A to D Ds. They have like gazillion bits of resolution, and the sampling rate is 96 kilobits per second, kilo samples per second. So he can run a Nyquist, he can run everything at 48 and do just fine. So he can generate signals at 24 kilohertz, and from there he boosts it to 40 megahertz, and from there he simply subtracts it from another frequency and puts you on whatever handband you want to be. So the modulation's always at 24 kilohertz. Demodulation works exactly the opposite. He takes everything down to a center frequency of 24 kilohertz, and then he demodulates it in math after A to D'ing with this cheap codec. The codec came from a CD player. They're $4 in quantity. It's a flaky little device that's a little touchy to work with, and that's caused him great grief, but it's dirt cheap, and it's just got zillions of bits of resolution and lots of inputs and outputs that do lots of cool things. So sort of a hybrid SDR. So if you look at a 7300, they have much faster A to D, D to A, but they still have to do some heterodyning to do 6 meters, if I understand their explanation properly. So I'm not completely sure how everything's done on a 7300, but I think they're able to A to D at much higher frequencies than Osher can because he's using stereophile equipment. The radios were blowing finals like popcorn. Now, I've never blown one. I've had 2 of these, and I've done tons of development with them, and I've done all kinds of stuff, and I have never blown a final. But these other guys, they blow them all the time. I don't know what it is that's different between me and them, but it turned out that he had something stupid in his design that nobody thought about, and he had a direct feedback path and a pretty high gain amplifier chain. So it made a VHF parasitic like nobody's business. I think it was a 200-watt parasitic. And that was pretty good at blowing the gate of the finals. I think I've got a slide here that shows you how this worked. Nope, that's not it. Well, rats. I thought I had the slide. Basically, what he did was he had a relay that did the TR, switching back and forth between transmit and receive. But the relay contacts had some pass-through from simple capacitance. And it was enough to allow transmitted energy when you made the transition and the transmitter still had power for a few milliseconds until the capacitor is discharged. It was enough that the output could get back to the input at VHF frequencies, and it was a virtuous cycle, kablam. So he had scope pictures of these VHF oscillations, and it just would develop. The gates on these things are good to 20 volts, and after 20 volts, they give up the ghost. So he struggled with how he was going to do this. And he talked about doing a diode switched unit. And he got this from, I always forget this guy's name. Hans Sommer, I think was his name. Built the QEX or something. And Hans has been extremely helpful. Hans was trying to bring out his own 5-band rig at the same time. I don't think Hans ever brought his out, but he helped Osher, his competitor, bring his out. So that was an example of real helpfulness. And he is using 1N 4007s as a PIN diode. They're 10 cents each. It turns out they have an intrinsic layer that was put in there to give them the 1 kilovolt reverse voltage, but they're power supply diodes. But you can actually use them as PIN diodes as long as you provide a little forward current. It doesn't take that much, and they work just great. And so he has a little power supply here that develops like 3 volts, and he has a whole bunch of switching MOSFETs that switch things. And the power amplifier connects here, and I think the antenna's over here. So this is a series parallel shunt to kill some signal when you don't want it. There's 2 diodes to provide some protection for the receiver. A lot of QRP systems use that technique that actually will provide some protection against EMP. So it's a very brilliant idea to do that. It does risk some IMD if you're in a high signal environment. But if you're in a reasonable signal environment, it's unlikely you'll get to 0.6 volts. We are going to potentially operate 1,200 feet from a 50 kilowatt FM transmitter for field day this year. And I'm a little worried because I calculated 0.6 volts will meet. At any rate, so he has transmit receive controls, and these 2 PIN diodes separate the receiver and the transmitter at all times. So there are no relays. And I just went boinkers. I said, you've got to do this. This could be a near full break-in CW transceiver, the first one in a long time. Because the way the ICOM does it is they clatter relays. Now, they may clatter expensive relays, but eventually the relay is going to give up the ghost. And to have a system that's solid state TR, I thought, this is nirvana. Now, it turns out an SDR has some latency. So it's not full break-in because it has to develop, it has to fill up its little FIR filters and all this kind of stuff. So they don't switch back and forth instantly, but still there's no relays. And I thought this was a huge improvement. Because of the way he did it in this, he only had to support received signals. So the forward current needed for the diodes was just a few milliamps. So it was a piece of cake to build this. And it actually worked. So things began to improve, but the improvements did not occur until after the talk that I gave last year here. One of the user group put a huge capacitor on the input side of the switching filter for the 5 volts, and it basically killed the 500 kilohertz intermodulation defect. So then they started adding these capacitors, and huge improvement in the purity of the output signal, particularly on 80 meters. So that was a big success for the ICOM, for the SBITX group. The Raspberry Pis finally became available and the price dropped. And I was finally able, on what I was willing to pay, I'm not paying $180 for a single board computer, folks. I was able to purchase a replacement Pi, and then I was actually able to get a backup. I gave up on, I'd already blown 2 Pis. I'm not building more power supplies for these things. I just used the wall wart on my development unit. It's not here today. It's back in the trailer, but it worked. And so I was finally able to turn my unit back on, which means I could get back into the, game. Now, apparently there's not a whole lot of hams with a spectrum analyzer. So I was one of the few guys that was watching the spectral purity of the output signal and crying foul day after day after day after day. You got to fix this. You got to fix that. You got to fix this. I raised the PA idle current. He had it at a really low 0.25. I went to 0.36. I got a little bit of improvement. Osher had done some huge work figuring out what was really going on with some of the spurs that we're getting. This was a tunable spur on 80 meters. You could change the frequency you were tuned to, and the spur would move. You could tune it to whatever you wanted. And if you went to 3.64 megahertz, the spur was on your frequency. You could watch the spur because the SBITX has a sort of a pan adapter, and you could watch it move in on you. It was really wild. And so the math indicated that the 11th harmonic of the operating frequency was mixing with the local oscillator and giving you this signal. It was perfectly tuned to get backwards through the IF. He has a crystal IF. And if you take the 11th harmonic of the operating frequency, which all transmitters have harmonics, even though they're small, before the low pass filter, it's inside the radio. It's adding to the local oscillator and going backwards through the same filter that the local oscillator is supposed to receive signals from. And that was what was causing the spur. The problem was in the SI5351 to some extent. It has 3 digital oscillators inside this one little 8-pin chip. And the ground connections have finite resistance. So since you've got RF currents flowing through the ground connections, they couple to each other. So that gave a bottom lower floor to what kind of isolation you could get. And the solution for that was run the oscillators more lightly. So they have a drive current control. And if you lower the drive current to 2 milliamps instead of 8 milliamps, it's just a software change. My spurs got a lot lower. So doing all that, and then I started adding bypass capacitors. So red is a bypass, 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 bypass. I just added extra chip capacitors on top of where Osher had his chip capacitors to add more bypassing. And I added one up here in the transmitter chain to try to bypass the plus V going to the transmitter chain. Turned out that one made it worse. What? I don't understand this. You know, there's something about the architecture. Somebody have to do a PhD on it or something, but I got rid of that one, but I kept all the others. And when you did all this, and I had stupidly put connections to the plus 12 volt line. Inside the SBITX, he switches the plus 12 volts to turn on some transmitter stages or turn them off. That means that the 12 volt line goes to the collectors through some filtering of every stage, including the pre-driver, the driver, and the final. And if you add any wire at all to that analog line, you have an antenna. And I had done that. to build a relay control for the output so I could drive my kilowatt relay amplifier with this thing. I had to get rid of that. You can't have anything connected to his analog plus 12 volts. Instead, this was scary to me because I don't like soldering the things that go directly to a Raspberry Pi. But it's much safer as far as signal purity if you connect to digital outputs. For money reasons, Osher does not buffer his input output to the Raspberry Pi. It's straight signals from the RPI. So you'd be very careful when you do this, but I did that and I was able to make connections to the digital outputs and no spurs. I got rid of that problem. So some of it I was the cause of. And when I did all this, my development edition became reasonably FCC compliant. I can't say that my spectrum analyzer is National Bureau of Standards compliant. I'm within a dB or so of -43 everywhere. And I said, this is good enough. I mean, from a radio that was -20 to get it down to these levels where it's at the worst, it's around the spec and a lot of times it's better. I was pretty happy. I pulled my external control and instead I got the output from a chip that's connected to the Raspberry Pi and I used it to drive a MOSFET and I used that to drive an opto isolator that I bought off Amazon and I had a relay output that could control my SB200. And that worked. And I've done that on both of my SPITXs. I have 2 of them and it's worked on both of them. So that was a big success to go to opto isolators. This is a picture of it's Amazon cheapy product. You get 10 of them for $10 or something like that. This was in the middle of me installing it and it ended up being a success. The next thing was one of the user groups started studying the insulators that are used. Let me check the time. Oh, we're doing good. Between the TO220 final transistors and the heatsink. Now, Osher uses dirt cheap switching MOSFETs. Therefore, AC power motors. They're not for RF. So instead of really fancy RDX F16 transistors that are made for RF and have fairly linear responses, he used cheap stuff, less than $1 each. And he sends out, like, you get this little package. Oh, we found another flaw, so we send everybody a pair of replacement transistors just in case you need them. What? I've never had a manufacturer just ship me packages. Here's replacement parts in case you need them. So I got replacement parts sitting on my windowsill at home. I've never blown a final, but I've got lots of replacements. So Osher used mica insulators, which is standard practice. But mica is not the best heat conductor. You can shave it very thin and it still is a good insulator, and that's how they get around it. But one of the guys in the group went to beryllium oxide, which is the standard thing that folks use for high power transmitting tubes. The only problem is if you machine it and create dust, it gives you a bad lung disease. So I wasn't too happy with that idea, but he had data that showed the temperature between the device and the heat sink had a significant gap with the mica insulators. And when he put in the beryllium oxide, that gap just disappeared. Now, the TO220 package is a crappy package. The resistance between the die and the tab is significant. I think it's like 2 or 3 degrees C per watt or whatever the unit is. It's not a great package. If you use a real transmitting MOSFET, it's got a much better connection for thermal, but you got to work with what you're given. So we wanted to not waste any more temperature on the insulator or on the heatsink. So this looked like a huge improvement. This is an improvement of maybe 30 degrees. That's huge when you're talking about a semiconductor junction. So the rest of us said, yeah, but we don't want to work with beryllium oxide. So it turns out aluminum nitride is also an insulator, and you can get it from China. So I bought 10 of them for like $5 plus slow boat from China shipping, $3. And they finally arrived, and I put them in. You have to keep water away from them. Water will hydrolyze it or do something bad to it. So I just put some thermal grease around it to keep water off. And it's about as good as beryllium oxide. I did a bunch of calculations, and even though it's fairly thick compared to the mica, it's much better. And the result is your heat sink gets hotter quicker, which is what you want. And the chip die is cooler instead of hotter. So if you make those changes, which you need to do, you will keep your finals a lot longer. Okay, I don't know how much I put in here, but I did other things too. Out comes the version 2 hardware. You got yours that you can hold up? So this is not as small as an ICOM 705. It's about 40% bigger than an ICOM 705, but you can actually work on it. You can get your fingers inside there and do things with it. Show them the heat sink on the back. Massive heat sink on the back. Now, one of the problems is they didn't waste much time polishing that heat sink. So while I had mine off, I polished it with 600 grit, and then I got some toothpaste and polished some more, and I got mine pretty smooth. So if you get it smooth, then the distance between the tab and the insulator, all those little gaps are not good. So when he put that out, not only had he gotten rid of the TR relay, he got rid of the relays that did the bandpass switching. Like, holy cow, this thing has no relays. It's all diode switched. So I was like, golly Moses, I'm tempted to buy one. But I'd already blown 2 Raspberry Pis, had to buy more Raspberry Pis, bought a development unit, months I had spent, so I waited a little bit. And then I saw one for sale that was used. And it was $100 cheaper, and I had the Raspberry Pi that it needed. And so I bought it. And the owner told me he'd never transmitted with it. And when I got it, the receiver worked right off the bat. This is a wild receiver. It has to start up right. Sometimes the codec isn't happy with you, and then turn back off, turn back on, it works better. They've come up with a fix for that, and I don't know if I've got that in mine or not. But I was going to test the transmitter purity because I just don't trust these things. And I made some measurements, and I didn't keep records of what measurements I made. So it's possible I caused what happened next. But when I measured it, it was terrible. It had all kinds of spurs. What? Asher, did you do it again? So I spent weeks and weeks and weeks. There are 300 entries on the thread that I created trying to track down what caused these spurs. And in the process, I learned an awful lot about the really elegant way that Asher built the TR system. At first, I didn't completely understand it. So at first, I thought, well, he cheaped out on the low-pass filters. They're just not enough stages. He cheaped out on them. He's got to. So I ran a spectrum analyzer plot where I put power into the low-pass filter. Dadgum, that is a good filter. Oh my gosh, his filters are amazing for such a cheap radio. So it's 55 dB of absolute isolation. The second harmonic or third harmonic could be identical to the fundamental, and it would still pass FCC. So it's not the filters. So what is it? So I wired the radio up and I ran it directly through one filter, and it worked fine. So somehow or another, the energy is getting around the filter. Something is not working right with the digital switching. Oh my gosh. I worked and I worked and I worked because he's got digital voltage. He's switching, he's got voltages everywhere. There's a voltage turning a diode on or turning a diode off. Oh, it's like a Pandora's box. It's such an elegant circuit. It's everywhere. So I tried blaming every single diode. Could it be this diode? Could it be that diode? And I'd solder them in and solder them out and measure it and measure it. Oh my gosh. There are so many paths of control because he has to switch exactly the right way between transitions. The 12 volt, get this working. The 12 volts can bias diodes. He has a RF picker, RF power supply that looks at the RF output and develops. It's sort of like how MFJ did their QSK switch many years ago, but it's much more elegant because he doesn't need a high voltage power supply. He pulls it directly off the RF output. And then he's got all these other controllers, and it just goes on and on and on and on. Very complicated pathways, days and days of testing, trying to figure out how is the signal getting around it, and I found it. Those two diodes were blown. The whole time they had been blown. And because of that, the high voltage output developed from the RF could not significantly exceed 12 volts because it was tied to the 12-volt system because those diodes were shorted. So that is what had gone on. So I think I've got yes. So what Asher did, he used a switching circuit that I think Hans and others had also used with a series and a shunt and a control from the Raspberry Pi. But the problem is this can turn on at the same time this turns on for like a nanosecond or two. But this is an IRF 409, which is a honking thing, and this is an itty bitty 2N 7002 SMD device. And if these two are ever on at the same time, which can happen in the transition, you blow the little bitty guy. So the solution for that is you put a resistor right here. So you need, where'd he go? He needs to add like 150 ohm resistor right here, and that will protect this transistor for forever. But that, he just cheaped out on that part of the circuit. So I soldered in a little resistor. And I think I skipped and didn't tell you. Yeah, I think I got to go back. I got to go back. You need a resistor in series with these, because the deal is somewhere or another, I must have accidentally grounded this line, or somebody grounded it with a VOM probe. Everything's tiny. And I may have done it, or the previous buyer may have done it, or someone in manufacturing may have done it. But those diodes have no series protection, and they're connected to a stiff 12-volt supply. So add a resistor right there, little bitty resistor, 200 ohms will do the job, and you'll never blow those diodes. Same problem with that set of, it's just a disaster waiting to happen. So Allison, one of the people on the system, had discovered that, and she had done it with a fancy TR switch, fancy delay, but all I did was add a resistor, and that fixed that problem. So it worked. Now it was fixed. Everything worked, and I had a radio that was no relays whatsoever, and it was just a great system. Okay, he started adding new code. Oh my gosh, is this guy ever going to quit? So he wasn't happy with his really nice, what I thought was really nice display. He said, no, I want you to be able to control it in a browser. So he wrote an HTML interface to this thing. And I was going to try to do a display for you guys. I don't think I'm going to be able to do it today because we don't have a way to get, this has got HDMI outputs. So this morning, I took the time to get a cable for you guys so I could actually let you see it, but I can't. At any rate, he wrote this HTML browser. So you can control this thing with a PC from across the room or across the world, if you can get a good enough connection to it. So the whole radio can be controlled from anywhere now. Well, that didn't turn my crank, but other people like it. So then I didn't particularly like his microphone. Where is it? What? I lost one of these. Somewhere in the process, I lost one. So I went to, Hamfest, and I just picked up mics, and you need a high output cartridge, but I started making microphones for SBitXs that I like better. So I started having fun with this. And mine now controls my SB200 amplifier just wonderfully. And it's got filters too, so it cleans the signal up even more. So doggone it, I can do stuff with this radio now. So I have my own SDR radio that I can program. So I've got 3 students taking pre-calculus, and we're going to have a science fair. So I said, well, what can we do with this? Well, older guys like me have a hearing deficit above 2 kilohertz. And it turns out that if you want to win contests, our group learned how to do some contests. You want to boost the signal level above 2000 hertz so the older guys can hear it. Well, I can do that in software. So I went into the FFT routines and I upped the 2000 hertz response from the microphone, and I made it computer controllable. And my 3 kids in my pre-calc class picked up real quick. Okay, here's how we control it. And I can kill the bass response. And then I can transmit a signal that is ideally suited for the older ear. And they can do a science fair project of intelligibility of nonsense phrases and hopefully win the science fair. By the way, I'm in charge of the science fair too. So we have that going, but my noise generation, I try to generate the noise to go against. My noise generation was terrible. Apparently, I don't understand the FFT as well as I should. So it just didn't work. But then I remembered I had this. And this is the coolest thing you've ever seen. This is built on a teensy, and it was produced by the WinLink guys, and there were only 150 made, and I have one of them. And it's controlled, and you put audio in here, and you get audio out here, and you pick what degradation you want. And it can do any degradation that the ionosphere can do. It can Doppler shift unevenly. It can shift frequencies down if you're mistuned. It can add selective fading at any rate that you want. And it can add white Gaussian noise and other things that I don't even know what they are. So I realized, although my noise is not very good, the noise that this thing makes is perfect. And next week, my kids are going to be transmitting again, and their signal is going to go through this thing. And you just pick what noise you want to add, and you pick what you want the signal to noise ratio to be, and it reads the incoming signal and adds the right amount of noise to get that signal to noise ratio. So I can do 40 dB better, 30, 20, 10. Oh, it gets hard to hear around 0. And at -5, you can't make out single sideband. So it's a really cool device. So my science fair project is back online. So then he came out with a V3. Would this guy please just leave the radio alone? So he comes out with another edition of the radio, right? And he's gotten tired of using the IRF Z24N because it still has a few problems with IMDs. So he drops back from 40 watts to 25 watts with IRF 510s, and as clean as all get out, according to him. I think he's telling the truth. I have the earlier units. I've still got 40 watts, and I'm happy because I like to do emergency communications, and I need 40 watts on 80 and 40. He has improved the connection to the codec. The documentation is getting better and better and better all the time. And then this guy in the user group develops, actually, Asher developed a telnet port. Not only has he got HDMI control, now he's got telnet control of this deadgum radio. When is he going to stop writing software? So then there's a user group guy who said, well, that's really cool. I'm going to develop an application so you can punch buttons and control the radio from a push button on any other radio if you didn't want to use the screen way. So he's got 56 commands that you can do. And then now anybody can have third-party access to the device. And so this is the telnet control that one of the users created. He's now up, he's had like 10 releases of this thing. He keeps fixing things. It doesn't do anything that I'm terribly fascinated with, but other people just love it. So then I said, hey, Asher, do you know nobody can run all of this software that's built for Windows on your radio. I mean, I know that Raspberry Pi is great and all that kind of stuff, but there are other software in the world. Not everybody just uses FLDigi, and he had a homebrew logging system that he's built. He's built a whole lot of software. But I'm like, trying to recreate all of ham radio software is maybe not the best use of your talents. So you need an emulator so it can look like some other radio, like an ICOM or something like that. Oh, they did not like that. I caught so much grief. No, we do it over the net, and we use net rig control and some other words that I don't even know what they mean. And I said, well, that's fine, but the guys that write WinLink, or that who here knows what Ion 2G is? Okay, well, the state wants you to use Ion 2G so you can do ALE communications to the state in the event of a disaster. In Alachua County, Volusia County, Flagler County, we have it running. And they actually answer our calls. It's really impressive. The first time we've gotten the state to actually show up and do something. But at any rate, we need some kind of interface. And I kind of like ICOMs better than Jesus. So I wrote an emulator. Why is my hand still up? Maybe this thing's got linked to it. So I wrote an emulator for an ICOM. Since nobody else would do it, I couldn't browbeat anybody into do it. So it took me a weekend because I'm really stupid. But I finally learned how to do it. And the first problem was you have to get a COM port to show up, because all these things depend on COM ports. And so that means you need a UART chip. And I don't know much about UART chips. So I didn't have any. So when I first did this, I had to take 2 programmers and use clips to go between the pins of a Baofeng programmer and an ICOM programmer. And each end had a UART in it. And I just connected the TX to the RX and the RX to the TX. I had to look up how each radio gets programmed, and it worked. I had COM ports. So on the PC, I see a COM port. I'm going to turn it on or something. Yeah, turn it on. Works better if you turn them on. And on this end, you gotta have a TTY USB 0. I thought you could just connect the USB to the USB, and no, it doesn't work that way. I didn't know that. Now, give me a second. I got to turn on some software. So let me see. I have this cool. All right, so this is the display, and of course I don't have a really antenna or anything, but you can see it's a really pretty display, and it's got all this pan adapter and all this cool stuff, and changing the filters is a piece of cake. And now I got to get back to here, and I got to punch this. I hope this works. Yep, it came up. Okay, so now my ICOM emulator is up. I didn't know squat about Raspberry Pis. I didn't even know how to make an emulator. Come on, please stay up. This Windows. So I just had to learn everything. I didn't know how to make an icon. The directory structures, I kind of have that figured out by now. Now, how many of you know what an RMS is? Close. How many of you know how to use WinLink? Okay, when you use WinLink HF, what do you connect to get your stuff done? An RMS gateway. So everybody knows about the software to run WinLink, but they don't know about the server software. And if nobody can run the server software, you're not going anywhere. So once I had this ICOM emulator going, there we go. It is now controlling the SBITX, and it is an RMS server. And it is running its 5 frequencies that it will run day and night, and it will search on all those frequencies, and if a station calls in, it would respond. Or at least it would if I would connect up the audio, which I haven't connected. But this was my nirvana. Can I get this thing to actually control this radio that has no relays? So if you're running Ion 2G ALE, you are switching frequencies like 2 a second. Can you imagine doing that with relays? Oh my gosh. So this thing can now run ALE. I've done it. And it can run all those frequencies because now I can run Windows software on a Raspberry Pi SDR relay. There isn't anything like this out there. I think this thing's unique. So at any rate, I got that done. My version 0.1 software stinks. It's like grade school software. Please don't throw too many tomatoes, but it will get better. This is some of the code for it. I use a free compiler, and I'm cheap. I'm not going to be climbing any mountains, guys. I don't need a fancy go box because I'm not diving underwater and I'm not going in the rain. It's got to have a driveway for me to be deployed there, right? I'm driving my car up and I'm getting my little roll around, and that's how I'm getting my gear into the room. So all I need is a plywood box that puts everything together. So it's dirt cheap, simple. The coax is already done. The audio connections are already done. I built my little current monitor. I've got outputs to where I can use any kind of microphone I want. ICOM mic works just fine. I've got the signal link already connected up. This has got it all built in, but I can't connect to it because it's a Raspberry Pi. And nobody has built the interface to give me direct command of the audio controls. They will eventually. There's a guy in England who just about has got it done. And I said, do you realize what I could do if you'd finish that? So I built the same thing for my development edition. This is the demo that I just did for you. One of the few demos that I've ever done that worked. And I want to show you why Osher doesn't know squat about WinLink. He thought he could recreate WinLink with UUCP. How many people know what UUCP is? Well, look, I mean, UUCP would work, but it took them 20 years to get 150 stations that operate 24 hours a day all over the world. You're not going to build that user community in a week. Osher lives in India. Where's it? There, right there. His closest RMS stations are thousands of miles away. That's why Osher doesn't understand WinLink. He just doesn't live in the same world that I live in the United States, where I'm interested in emergency communications and I need to run Ion 2G, or I need to run PCALE, or so he just doesn't understand. So, nobody's perfect. Okay, so they dropped the price. It's now $3.99. So yeah, you can go get a Zygu, and there's a bunch of people that got Zygus, and apparently new firmware comes out for Zygus, but you can't write your own. It's going to be painful. And this thing, I have all the software, and I frequently muddle with it and change things, like for my high school students, and I'm going to change the receiver. So it gives them a hearing deficit in the receiver. So they can appear to be a 65-year-old guy with crappy hearing. So they can actually play with their own software and pretend that they're an old guy. Oh, it did make it better. So that's what we're doing this week. And it's all because I have control of everything inside this radio. And now that we've got the RF part worked out, this is a fantastic thing for anybody who wants to really play with ham radio. And I'm convinced that ham radio does not exist because a lot of people have radios and can push buttons. We did an exercise once where we teamed ourselves up against the fire department. They have radios too. And they have fingers too. And guess what? They have these little bitty notebooks, and they are way better at passing traffic than we are. They ran circles around us. More accuracy, faster throughput. We're all doing all this radiogram stuff or whatever and net control. And they're just, we got a wreck on such and such. And we've got a loose Godzilla on this street, and we need 32 flying cars to be delivered to this location. They ran rings around us. So if the only thing that ham radio's got is a bunch of hardware and push buttons, we're not going to stay around, folks. The way that we've got to stay around is 97.1. We have to provide a cadre of trained experts who understand electronics and provide benefit to the nation, like teaching my high school students. Ham radio is a benefit to them. We're not asking them to service us. I'm servicing them with ham radio. That's my thought. Okay, any questions? How do I get there? Will the SBitX version 3 replace the RF board of a version 2? Daryl, you don't need to. The version 3, all it did was take out the really nice 40-watt transistors and replace them with slightly ruggeder 25-watt transistors. So I wouldn't bother. What you need to do is add the 2 resistors that I talked about, change out the insulators because he's still selling it with mica, I believe. Grind out the the surface of the heat sink. Takes about 5 minutes. Put it all back together again, and you can have a much better radio. Yes.
So no, that's
Yeah, I'm not changing mine because I got 40 watts. And the new one is 25 watts, and I like 40.
I got 62 version 2. I got it in the fall.
And if you want to run Windows, then you download my little emulator for ICOM, which stinks, but it works. And now you can run Windows stuff. And if you want to run, you can use, he's still got this HTML controller, and he's still got it's like wild. I mean, golly, there's too much to this radio. And any, it's got advantages and disadvantages. So you, that's not the mouse. You can control the power any way you want with the drive command right there. And his newer versions actually have an SWR bridge and a power meter built in, so you can read how much power you're using. So you can get it down to anything that you want. The disadvantage, this is an SDR radio, so it's running a Raspberry Pi. That's a power hog. But he's got it running on a Pi 2W. It's a little single board job that I think uses maybe a couple hundred milliamps. So that's a much better version if you want to do QRP. And these solid state radios use crappy transformers. They're only optimized for one power. All of us use Pi networks, 2 controls and optimize it at any power level you want. They can't do that with solid state. So the efficiencies aren't as good, but it still works. Did I answer your question? Anything else? Yeah. Yes. And I've been thinking about that because I'd like to do some microwave work. And all you got to do is turn the power way, way down. When I work with my high school students, I set the power at 1%, and I use 30 or 40 dB between the receiver and the transmitter, and they talk directly to the receiver. They talk over ham radio all through coax. And they picked it up immediately.
Because some coax is legal.
Yeah. All right. Thanks, folks.
Okay. Let me have your microphone.
Oh, here.
I was thinking about ordering the version 3 board, and now I won't have to. So now just change out the insulators and so forth, and we'll be good. So, okay. I guess a little bit of housekeeping here before we go into our next 2 presentations. And I'm looking at this video running delayed, of course, due to the internet here. So who is going to pick up for the money for pizzas or whatever? We can order a dinner to what we did last year. I got to contribute too. Just somebody volunteer to pick it up. Somebody willing to do that? No. All right, Angel. Okay, you have been picked, sir. Thank you, Angel, for doing that. All right, and so just go see Bill and one CDO. Let's see when we get our next presentations. You just slip up quietly and go to him, and then Angel's going to go pick up our pizzas for us. And Bill, where is he going? You'll need to get with oh yeah, here we go. Now put that in. Yeah. I didn't have any change. Just I'd say $5 a person. I should do it. So, yep, that radio is quite a fascinating radio, the SBITX. It really, really is awesome. Now we're going to go ahead and segue into our next presentations. So again, go ahead and chip in now, and Angel, you get with Bill and you decide what place you want to go to get them, and you work that out. And gentlemen, I do appreciate your help. All right, the next presentations, we have 2 tracks this hour. We have in this room antenna modeling using ESNEC, AutoZ, and a book. This will be Mike Hembry, KV000M. Yes, it's Kavoom. That's what it stands for. And in the second track in the back room, Gordon is going to be going again this hour. He's doing a marathon today. He's a college and high school professor, and so I guess he can handle it. But I do appreciate him stepping up to the plate and filling us in some really fantastic programs. 11 o'clock is how much protection do FCC Part 15 conducted noise limits provide? And you can't see it on camera, but it will be recorded. Again, just a reminder, this is being live streamed to our YouTube channel, and the audio has turned out pretty good, which I'm very pleased with. Russ Delaney, N4RTD, is going to be, I'm going to go ahead and get that slide presentation up for you, so you will have it. And he's going to do post-production editing and cut these into individual ones and add the slides in. Now, the 1:30 program this afternoon. Oh, okay. Sure. Oh, okay. Well, thank you. Change. Oh, okay. Yeah. Here, I'll contribute another 5 for some extra. Well, there you go. All right. And so let me go and get Mike's program queued up here. Oops, I'm on the wrong mouse. I got 2 mices and it's too many. Okay, oh, there he is. Okay, I just found it. There we are. I always have to forget on these G7s, you got a whole function in F5, you get to start. So Mike, are you ready, sir? He maybe stepped out for a moment. This afternoon, just a little bit of housekeeping. At 13:30 hours, we come back from our long break, and I call it dinner at noon because I'm from the South. It's supper in the evening, amen. But anyway, our long dinner break, which I give you an hour and a half on purpose. This one gives a chance for our speakers to rest. Number 2, time for you to socialize and talk about and exchange ideas. I mean, to discuss them. That's what TechCon is for. And believe it or not, we've had 7 to 9 watching the stream this morning. So you may be thinking the attendance in person is less. Well, the people that watch the videos are 30 to 60 after the fact. So you're thinking, well, it's not that many in person. The things have changed. And I struggle with this, but don't be discouraged. You just keep coming and participating, and hopefully more folks in future years will come and participate. So seeing where Mike is at, he must have to step out just for a moment. Does anyone have any special announcements we'd like to make at this point before we okay, see him. I guess Mike went to get his stuff. By the way, the papers for the conference, I'm not going to have time to load them today. I will bring the links up today or when I get home, depending on how tired I am, or tomorrow when I get done for church and get home for the day. So all you'll be actually, Gordon and all his programs produced a PowerPoint, Open Office Libre presentation, and a PDF. So it's a readable document. So you're going to like that, reading that on your computer. And so, Mike, I got your presentation up, sir. And whenever you're ready, it is your turn, sir. That's okay. This is ham radio. So there you go. So folks, again, I'm going to put out a call here. We need speakers for next year. Our folks are good presenters, but we need more. More is better. If you have a program, something you tried and failed, that's okay. You'll tell us what not to do. Please get with me and we'll put you in for next year. And okay, Mike, we're going to turn it over to you. And on antenna modeling using ESNEC and AutoZ or AutoEZ, excuse me, and a book. And you can clip this on and use this one. Just clip that on.
Okay, I hope they can hear me on this thing. I hope they can hear me on this one too.
Yeah.
First, would you mind taking a picture for me on my camera? The little white circle is a picture. I want proof that I'm here instead of sneaking off fishing. My new girlfriend doesn't trust me yet.
That's your evidence.
So,
Oh, that's a fast zoom on it.
whatever you can do. Thank you. Okay, now that we got the important part out of the way. How many of you have tried antenna modeling with any of the programs?
Want to bring that mic up closer?
Oh, tried antenna modeling with any of the programs? Excuse me. Okay. If I tried my name is Mike Hembry, call sign KV0OOM. The call sign is also on my license plate. It took me a while to get something that worked both with the FCC and with my licensing bureau. Unfortunately, in Florida, 0 is not on the license plate. And that's one of the few states I think that does it, but I believe it's because a 0 and an 8 look the same. And the cops can't tell the difference when they look at your license plate. So I end up with KVOOOM on my license plate. But if anybody that sees it says amateur radio on the bottom, you know that third character is a 0. I got my tech license. I'm one of the newbies in the amateur radio game, although I've been in electronics as an instructor and service engineer all my life. November of 2014, I took the novice test and passed it. They said, "Do you want to take the general?" I said, "No, I didn't study for it. Did not study for it." Then they said, "Okay, well, you can take it for free. You might as well try." I took that and I passed it as well. So I got both of them. Fortunately, my electronics background helped a lot. A few months later, I went over and come over in Tampa and took the test for the extra. I said, "Okay, I'm going to take the test." I did some studying for the extra, and I'm going to see how I do. And then I know what to study. Well, I passed that one too. So I think I just barely passed it, but I did pass it. So I went from nothing to extra class license in about 3 months. And my electronics education, and I also was an instructor, that really paid off. So knowing electronics is important to ham radio. Don't let them give that part up. Don't let them dumb down amateur radio. I'm also an ARL WCF technical specialist. That means Daryl puts up with me. Computer programmer, and I'm hobby poor. I have a whole list of hobbies, but include astronomy, amateur radio, working with a desktop laser and desktop CNC machines. Too many hobbies and not enough money to support them. And being retired, that means I'm on a fixed income, so that makes it even worse. I can't work overtime to get more toys. My past modeling experience, EasyNet, big fail on that one. I just didn't understand it, and I'll explain why a little bit later. But EasyNet, 4NEC2. I made a long wire dipole In my backyard, I have about an 80-foot span, and I needed about 160 or 140 feet or something. So I made it U-shaped. Went across the back, one side went to a pole I put up between my house and the next door neighbor's house, and the other side dropped down and ran across along the neighbor's plastic fence. So that was my example. It worked fairly well for a long while, but that was the only thing I was able to actually model with any of the software. Neck2Go, I bought that one at some ham at the Orlando Hamcation. And Neck2Go was parametric, where you use formulas and stuff, and I really did not comprehend that. So I spent the money and supported the ham, but that was about all I accomplished with that one. MiniNet Pro, big fail. That one didn't. M-Anagal, yeah, another fail. So you can see I was not doing very well with software for antennas or for antenna design, so I ended up using the internet to do my searching. And hopefully I would find an antenna or something close to what I was wanting to experiment with. Bought a 6-meter beam from MFJ, which also is a Cushcraft dealer. And I bought this thing and assembled it on my back porch, and it's been there for 3 or 4 years for reasons unknown to me, other than I just did not take the time. It did not get put up. But fortunately, I was lucky to wait or procrastinate because this software came along that I could work with, which we'll be talking about here shortly. The coax path is figured out. I have a Titan DX, Gap Titan DX antenna in the backyard, and I run a buried coax, and I buried it in PVC pipe so I could snake more coax through there if I wanted. And at the antenna, I have I think 5 relay or 6 relay switch box, antenna switch box. So I feed multiple antennas from there. I figured, I can't afford to run 20 or 10 or 15 coaxes out through the backyard. And then from there, I branch out with PVC pipe to various antenna locations. I have not run the PVC pipe or dug for this the 6-meter antenna, but I have everything in place and about ready to put it up. You see here what I did. I downloaded EasyNet 7, which is now free. I think this was originally a $500 or $600 package. And when I saw that it was free, because the guy that wrote it retired and turned it free, I said, wow, I'm getting that one no matter what. Even if I don't know how to use it, I'm going to get it. And then I saw a reference on his website to AutoEasy, which is a software package. And I saw the book, or bought AutoEasy, and I said, now this is cool because it's actually an Excel spreadsheet. It's not a program, it's a spreadsheet with programs, code in the background it runs. And it's pretty nice package.
Does it give you a pattern?
It does everything EasyNet does, and EasyNet does and more, way more. And then on the AutoEasy site, I saw a reference to a book. And let me go get that book. The book was about $50, if I remember right. That's the book. This thing is huge. And it's stunning how much information this guy put in here. It was written by a guy named Marcel Descanques, which just recently passed away. He passed away back in October. And the first 12 or 13 chapters in the book are basically using EasyNet, not using AutoEasy. And this was really handy. So I bought the book too when I saw the reference. I'm glad I did. My first use, you see on the upper on the screen, I used Easy Neck and Auto Easy and the book January the 6th. Yeah, that was the first time I opened the package up. I was up in New York spending Christmas with my son up in New York, and I had something to do. You know, I always try to do something up there to keep from going crazy. And 2 days later, I knew what I had to do for a presentation. This presentation was formalized in 2 days, just by playing with the software and making stuff happen. Auto Easy requires Excel 97 or later. None of the knockoff spreadsheets work. Google Sheets or whatever, Open Office, I have a whole list of them. None of them. It's strictly Excel. But fortunately, you can get a cheap copy of Excel. Even Excel 97 will drive the software, so you don't need a expensive Office package. You just buy something off the internet, and it'll work. He also has this book here, like I said, first 13 chapters. It's totally amazing how much information is in here. Even if you don't buy Auto Easy and you use Easy Neck, buy the book. You would be surprised at how much you don't know. You know, it's an awesome book. I sent a email to Marcel about broken links to the website, because it says link here, download, and unfortunately, I got an email back from his, I believe she's daughter-in-law, and she said, Aggie, I guess how you pronounce it, her stepdaughter, and she said that he passed away back in October. So anyway, so there's no more coming from this guy. That's a real shame, because he writes with a style that most technical books should adopt. It's very, very detailed, very simple. He explains everything. Now, I mean everything. He doesn't leave anything to the imagination. So even if you don't buy Auto Easy, buy the book. Okay, now, I modeled my Cushcraft antenna with without stepped elements, and I thought, man, this looks good. I had a nice SWR curve. Everything was pretty. Then I modeled it with steps, and the SDR went something gazillion, well over 100. So I thought, well, okay, I'm doing something wrong. And anyway, I thought, well, no wonder people complained about the 5-element antenna that said it sucks. Everybody says that. And it's a 5-element with a gamma match for matching to the antenna. And I decided, and then I decided.
Model a gamma match in both these Easy Neck and Auto Easy, both of them. Can you model a gamma match?
Yes, you can. But to find out how, you need to buy book 3 of his antenna, practical antenna book.
A different one?
Yeah, it's a different book. It's called Practical Antennas or something like that. And the volume 3 is where it has it. I did buy all 3 of his books on practical antennas.
Same guy, Marcel?
Yeah, same guy. And but those books are strictly Auto Easy books. They don't, help you on Easy Neck. But if you got this one, who cares? Anyway, with the help from the book, it was really quick to learn. Applied variable names and then got error messages. I said, okay. I said it a little different, but okay. anyway, I found out that because of the software has certain rules, which all software does, there are some variables you cannot use, variable letters you cannot use. They're already assigned. And as long as you learn to skip over those, the C, F, and R, and I also don't use H. You skip over those, you're okay. If you need more variables, there's plenty. You can see from AA to CZ and the original 22 that you can use in the alphabet, you'll wind up with 100 variables. If you need more than that, you need to go some other software package because, you know, that's just a gazillion. This is out of the assembly manual for my Cushcraft antenna, my 6 meter, I'm going to call it 6 meter antenna. As you can see, they have a chart and they have an assembly instructions. For some reason, or I don't understand really what's going on, but for a vertical positioned antenna, as compared to a horizontal, they have a separate table with separate values in it. Now, I kind of always thought this, that somebody said, if you want to check your antenna SWR, a horizontal antenna, flip it vertical if you're down close to the ground, and you do that. You know, it's what I read somewhere. But this tells me, the two charts tells me that's not going to work. So anyway, there's the chart. Those are the values. And good luck with it. Those of you that use EasyNet, you'll probably recognize some of this. This is the wires table out of AutoEasy. Basically, N1, N2, diameter, number of segments. It's just like our EasyNet. Reason I don't know if I'll say this later in the application or in this presentation, but the reason I could not use EasyNet is because in EasyNet, there is no empty wires table. I mean, that's a very simple concept, but you can't have a spreadsheet in EasyNet that has nothing in it. You have to have an entry, no matter what it is. You have to have one antenna element. Then you can build on that and delete that one if you want to. But for that reason, I could never get EasyNet to work. That's what I learned in the book. It said in there, you cannot have an empty row or an empty table in EasyNet. Now in AutoEasy, you have your wires table. You also have a variables table. If you're used to using a spreadsheet in Excel, you can have multiple tabs along the bottom and have your different spreadsheets in a workbook, I think they call it. Assign your variables, and you use this form right here. I tried to use C and it failed. Of course, I found out later, shortly why it failed. And then I tried to use apostrophe, which says, okay, that means go ahead and accept it as a text character. Me not working with Excel for a while, it didn't dawn on me that that's not how you do it either. So but it won't fail. That's what threw me for a loop. It won't fail, but it won't be a variable either. It'll be equal C in that cell. So anyway, stepped elements. You assign, if you have a stepped elements antenna, the middle section is fixed. So the middle section is fixed. You don't want to assign a variable to that one. You want it to stay fixed. But the elements, end elements, or multiple steps if you have them, there's where you assign variables so they can adjust. once you add your variables to the wires table, when you add them, if you have your variables defined, excuse me, if you have your variables defined in the variables table, when you go in and cell and put equal A in for that cell, or equal B or whatever your variable is, when you hit the enter key, it will pop up the value that you have in your variables table. So if you're using a value from that table, or using a value that was a fixed value initially, like, 400 millimeters or something, and you switch over to a variable, if your variable is 400 millimeters, it'll show the same thing. So that way you can actually confirm that you're putting the right one in there. After you add your variables,
Is this the auto easy or?
auto easy. All right,
Oh,
we're
okay,
speaking auto easy. Yeah. Once you add the variables to your wire, put your variables in your wires table, you go back to the, add the variables to the wires table, go back to the variables table, and there's a button that says optimizer setup. Basically, what you're doing when you click on that is there's a little button up here that says optimizer setup, I believe. Can it read? Yeah, optimizer setup. This screen's tiny. And when you click on that button, you'll get a window that pops up. Now you don't have to optimize or calculate with all your variables. You can do just any 1, 2, 3, or whatever you want. So you select your variables, and then once you do that, did I skip a page? Oh, it's next slide. Anyway, once you do that, it'll pop up the optimizer tab, because you won't see the optimizer tab in your spreadsheet until you tell it use a variable. I mean, why do you need optimizer, using variables? Now,
What does that mean, iteration?
iterations is loops. In other words, it'll run a calculation, then it'll step to the next frequency or the next element, and over band. In other words, you tell it what frequency you want this to run for, like a center frequency, and it'll start generating all these antenna lengths and SWRs and so on for each frequency, or for that frequency, to optimize the antenna at that frequency.
What kind of step size does it use for the different frequencies?
You can tell the frequencies variable, but right now we're just optimizing for one frequency.
Even at one frequency, it did 700 iterations?
Yes, it did 700 calculations for this thing, and it tells you how many it did. As I homed in on the ideal values, what I did was I changed my variables, and basically I ran the thing again with values closer to being best. And as you do this 2 or 3 times, you can get that loop counting, the iterations or the calculations down. It becomes less and less, because it doesn't have to go so far out to figure out what it needs to satisfy the conditions that you've set for the parameters, like SWR or whatever. Right here is where I did a boo-boo, okay? I put a variable A on one end of the director, or driven element, whatever, anyone, and I put a variable B on the other end, okay? What that did was that allowed the optimizer to move things in and out this way. so I could have a long left side element and a short right side element. And the optimizer would handle this. So, and obviously that was wrong. So what I did was I said, well, okay, I'll average the two, plug those back in as new A and B variables and run it again. I sent a letter off to the guy that wrote the software. And I don't know if I mentioned this later, but I sent a letter off to the other guy who wrote the software, and he said, did you use A for both ends? You know, pretty simple question. I thought, what? Then it finally dawned on me. I could use one variable in two places on the wires table. In other words, on the left end, I use equal A. On the right end, I use equal A. And then the antenna would go symmetrically in and out as well as doing its calculations. So, yeah, that was my reaction too. Oops. Anyway, to do the optimizer run, on the optimizer page, you'll get the start button to run it. Over here, in this section right here, is where you set up the parameters that you want to obtain. Good SWR, good low impedance, and what values you consider acceptable. Like SWR 1.01, that's the target we're shooting for. So you can see resistance, X impedance or reactance, SWR, antenna gain, front to back, or front to rear. Those are two different things, but front to back is your basically front to back ratio. Front to rear is like efficiency or something. I don't know, but they're actually different numbers. I'm not an antenna specialist or engineer. I'm just a guy with a bunch of toys. So, but anyway, I usually set mine for SWR and let the others float. Let them go whatever they want. Now you run the optimizer, and now you have to run, if you want to see the SWR curves and charts and so on that this thing can provide, and it's pretty comprehensive, then you need to run the calculate. The calculate's what you normally run anyway. When you click the SWR button in EasyNet, that is actually doing a calculate to create the SWR, the radiation pattern graphs, and so on. Not a pretty picture, is it? This was my optimized 5-element antenna, according to the computer. 1.5, it crosses 3. This was set for, I believe, 51, optimized for 51 or 50.125. I believe, is that the calling frequency on 6 meters? Or maybe it's, yeah, it's 50.125 megahertz. And the 3-to-1 is right at 51. So much for a wide bandwidth antenna. Yeah. It sucks, obviously. It can definitely be improved. Obviously, I was not impressed with the restrictions and everything that I had, including the length of the boom. That's also a variable if you want. I could not get anything really good. Then I read somewhere some ham took the 5-element antenna, took one of the elements off, and worked out something that made it a better antenna with only 4 elements, which I think Cushcraft could have done originally. I think they just really stuck another element on there to charge more money. and tried to get it close enough. So anyway, I deleted the third director, the guy in the front, and started over, see what I could do with a 4 element. Well, that was good. So, okay, yeah, well, let's try again. This time, I kept the boom same distance. It's about a 12 feet. It's a 140-inch boom, if I remember right. And versus 144 is 12 foot. So the element lengths or spacings were assigned as variables, and that includes the spacing between the reflector and driven, and between the driven and the first director. The second director position remained fixed because I did not want the overall length of the boom to vary. You know, I had a fixed boom, so I just the reflector and director 2 distance was a fixed value. And then I assigned the highest priority SDR and lesser values to the remaining optimizer parameters. And let's see what we get. Not bad, right? So as you can see, the SWR over this bandwidth from 50 to 52 is below 1.2. And right there's the SWR 1.5 SWR line. So now I got a really good antenna. So, okay. Yay. But the game is not over. Life deals you some wins, but often they're short-lived. My gamma match meant that my antenna had to be split in the middle. I'm sorry. My gamma match meant it was not split in the middle. What I was working with was assuming that it was 2 segment elements, one on each side. So anyway, I read an article about modeling CBIC. This guy is the antenna guru of all time, hands down. And it painted a pretty bad picture on gamma match. You know, his version of, or his story says, nah, good luck. And pretty much what it amounted to. He also mentioned that the elements shorted to the boom would change things because that's the way my 5-element antenna is made. It has all elements connected to the boom. And excuse me, but he did not explain how it made a difference. So anyway, I hate a moving target. And that's what this thing is. Of course, I think everybody knows antenna design is 98% art and 2% engineering. You know, it's just, who knows? You know, it's just pot luck on what you do. Even if it looks good on the ground, you put it up, it'd be way different. You know, that's the nature of antennas, but that's what makes it fun. It's never boring, that's for sure. Dan McGuire is a creator of Auto Easy, and I asked him about the different on the ends, and he replied, and I would go, oh, okay. Mystery solved. That also made it a lot easier on me too, because I was working so many variables, you know, one for each end on each element. Now it's just one variable for each end. So it's one variable per element for the length. Some last minute notes. I looked into purchasing the NEC 5 license. When I originally looked into it, I read on the Lawrence Livermore site that the NEC 5 license was for 3 years at $110 for license. I thought, well, no, I don't buy renewable software, at least not unless it makes sense. So I said, okay, I'll just pass on it. And I decided my modeling package was complete. I figured I got real nice package for $80, $50 book, and an $80 software package, and a free $500 software package. I've got a nice modeling system, so I can do my antenna work.
So why'd you buy V1, V2, and V3?
Because this book right here was written so well that I thought his other books will probably be written with the same style. And I was right. He's full of practical antenna books.
Are they the same book, but different revs?
No, it's volume 1, volume 2, and volume 3. It's 3 different books.
You have to get all 3.
Yeah, if you want the full set. So I did buy them, and they were written in the same style. Like I said, though, all 3 books are written basically for Auto Easy and not so much for EasyNet. The volumes are also 8.5 by 11, just the same as this one, but they're only about so thick. They're about 200, 250 pages or so. And I thought, the guy has passed away. He's not writing any more books. I'm going to buy what I can. He has other books too, but I decided I don't need those. Right here cost me $110. The NEC 5 one-time loan, the 3-year is just simply a renewal for address keeping purposes from Lawrence Livermore. Once you buy the NEC 5, and you also get the NEC 5-13B or whatever, because you get actually 2 down, 2 downloads. So once you get it, then you have a, a very capable software development package. The NEC 5 engine overcomes some of the error problems that you run into with using the NEC 2 engine. And also it overcomes one problem you run into using the Auto Easy software with the NEC 2 engine. Right here, I would get, when I was using, when I was using the gamma match, which I got from the Practical Antenna book, volume 3, because he goes with the delta, the gamma, the T match, just every match there is. He shows how to do each one in the book. So you don't have to figure this stuff out. I mean, it's that good. And it actually works. The, excuse me, my allergies are acting up. Anyway, I did buy the NEC 5 package, and I asked about the elements, and Dan said that the elements shorted to the boom are not relative below the VHF, which at 6 meters is kind of maybe, maybe not. But I figured, okay, who cares? I'll go with shorted elements and just not worry about it. I imagine you would have to actually create wires between the elements along the boom length and let it figure stuff out with that too, which the NEC 5 engine can handle, no sweat. There's a NEC 5 and a NEC 5 13B. The 13B, I believe, solves some errors that the NEC 5 engine had. If you go and read into this, dig into it, they'll explain what the errors were and what's the solution. But Lawrence Livermore gives you both of them. So if you want to deal with the errors and have fun, that's okay. You can do that too. Okay. There was, where we at? Farther, excuse me, farther along than I thought on the time. I was going to say a 5-minute break, and I was going to do an auto easy demo and actually take an antenna we picked up in a yard sale called a CB radio antenna, 2-element. And I was going to chop some off the elements because 2 meters is below the 10-meter band, turn it into a 10-meter 2-element antenna and optimize it. And
What software?
huh?
Using NEC 5?
No, at the time I was on NEC 2. You know, I just recently got the NEC 5 license. And anyway, like I said, if the demo was going to go south, it'd be my fault because I've just started this stuff, just started playing with it. Anyway, fortunately, we don't get to do this because they do not have HDMI capability on this. It's not working. So I can't use my computer to do the demo. It was just where I was going to run it. Later today, we have free time. If you want to watch it run, we can do it. Because I can do it here on my computer. Just, yeah, something like that. Yeah.
So you haven't used your NEC 5 yet, huh?
Yeah, I plugged in the NEC 5, told EasyNEC to use NEC 5, and ran one of my examples, and it didn't make any difference. So I said, okay, it's working. Now, I didn't.
Confusing to me. How can you get auto easy to run NEC 5? Do they have a way to do that?
Okay, here's how it really works. You have to have auto easy up and running to use, EasyNet up and running to use auto easy. Because the spreadsheet makes calls into the EasyNet software and uses that engine to do its calculations.
Thank you.
Okay. Now, EasyNet won't do a whole lot of what Auto Easy can do. It does a gazillion more. A much better display package, easy to work with. If you work with spreadsheets ever with graphs and stuff, you will love it. Excuse me. Right here, another reason for using Auto Easy. When I ran AutoNet, hit the SWR button, it generated an error, and I thought, what? Because there was no explanation. The internet did not explain what the error was. When I ran it with the antenna, show antenna button, show do the calculate button in Auto Easy, it explained the error. Same error, but it made sense. I said, oh, okay, that's what I did wrong. So that right there, in one fell swoop, it paid for the software because it solved a problem I would not have been able to solve. And now the real fun begins right after the break. Obviously, there's no after the break because there's no demo to run. Thank you very much.
If there's any questions on the chat,
Okay.
and then we have our hour-and-a-half break. Let's see if anybody's on the chat.
Right. Tell me where it starts.
Okay, let's see here.
You read the question, I'll answer them.
That's what I'm going to try. I just got to scroll. Nah, I need my mouse over here. When I have an external mouse, the internal one's turned off.
Oh, Mine stays on.
Yeah. Nope, there are no questions in the chat that I see, so. All right, and thank you very much for the good presentation.
I don't, thank you, sir. I don't know if that was a good or bad. We got no cat.
The audio was good, so.
No, I mean, did they like the material?
Yeah.
And it is recorded and will be edited and the slides will be put in.
Question.
So.
Yeah. Yeah. I was never comfortable taking my laptop computer to the bathroom. I always take books. Yeah, I gotta have the.
That's why you gotta have the paper version for the throne.
Right.
And of course, you know, you can take your iPad too, or Android tablet. Okay, well, this time we're going to end the stream to the internet here. And I've just got to get over here. We are going to go for our break and then we'll come back with the next stream here. I just got to go into that. So we will be back around 13:30 hours or 1:30 p.m. for civilians. And the other track is being recorded and all the slides will be introduced into the post-production process. And thank you very much. And we'll see you at 13:30 hours.